Welcome back. Today we are looking at our final method for solving quadratic equations, and then we're going to take some time to look at the solutions to our quadratics. So just to recap, last time we reviewed how to solve quadratics by factoring. Now remember, that's only doable if our equation is factorable. We looked at solving using the square root method, and that was only possible when the middle term of our quadratic was missing. Let me just go to my scratch paper. So if we had something like x squared plus 3x plus 2 equal to 0, then we could solve this by factoring because there are factors of 2 that make 3. So we'd say x plus 2 times x plus 1 equals 0, and then our solutions would be -2 and -1. Now if that middle part is missing, so if we just had something like, let's say x squared, I don't know, plus 5 equal to 0, well then we could just get the x squared by itself, and then take the square root of both sides, put in a plus or minus, and we could take out an I and leave the 5. We still get our two solutions. It just, might not look so nice. And then we said, okay, what if we had something like x squared plus 2x, I don't know, plus 9 equal to 0? Well, this would be a good candidate for that process called completing the square. Can't factor, because there aren't any factors in 9 that make 2. Right, this 1 and 9 or 3 and 3, not going to work. And I can't square root because this is here. So we said, let's complete the square. We take the constant, move it to the other side, and then we do a little magic here, right? And then we go about this process and end up using the square root method after we've made this side factorable. Now, I like this when a is already 1 and when b is already even. But let's say we had something like x squared, or let's say 3x squared plus 5x plus 1 equals 0. Well, this is not going to factor. There aren't factors of 3 that make 5. Can't square root because this is here. So right now the only option is complete the square. Now, completing the square requires this to be a 1, so I would have to divide everything by 3. Then I'd have an x squared, and a 5/3 x, and a 1/3. Then I'd have to move the 1/3, and then I'd have to find half of 5/3, and then that's 5/6, and then I gotta square that, and then I'm adding 25 over 36 here, and 25, it's just, I'm purposely making this an ugly mess down here because there's just, it's not reasonable to try to use that process. Is it doable? Absolutely, but I would never use that process for this particular problem. Now, I like completing the square. Now, if you don't like it, then this problem here, where we can't factor or use the square root method, I'm going to show you another method. And now for this problem here, this is, in my opinion, the perfect candidate for this last method, okay? So if you don't like completing the square, you don't have to use it, but there are cases where completing the square is ugly, and that's where I would use this last method, which is called the quadratic formula. So technically, the quadratic formula can be used to solve any quadratic, right? It's called the quadratic formula not because it only solves certain quadratics. It can be solved, or it can solve any quadratic as long as that quadratic is in standard form, okay? That means we need ax squared plus bx plus c to equal 0. In order, all multiplied out equal to 0. If you've got that form, then you can take the a, b, and c and plug in, where a is your number in front of x squared, b is your number in front of x, and c is your constant. So you're going to plug the values in. You can see 2 spots to plug in b, 2 spots to plug in plug in A and 1 spot to plug in C. Now when you plug in, especially because you're going to use a calculator to do most of the simplifying, make sure you use parentheses. Particularly here and here when you plug in B, if you don't put those parentheses, you're going to make some sign mistakes, okay? Even if you're using your calculator. So make sure you're plugging in with parentheses. And then we have to try to make this look manageable. So once we plug everything in, the goal is going to be to simplify here. Underneath the radical, we're going to try to get one number. And I'm going to use my calculator to do that. This calculator to get one number under the radical. So let's simplify the radicand. And then if it's possible to break that down, then we will do that. right? We'll simplify the radical. Once the radical is simplified, if our fraction is reducible, we will reduce. Now, I want to show you on scratch paper what that's going to look like. So you might end up with something like 1 plus or minus, and then let's say you get a radical 17 and you got a 3 on the bottom. I don't know, just making something up, okay? If this is the case, this fraction has 1, 2, 3 parts. None of these parts have anything in common. That means this fraction could not be simplified. But let's say you had something like 2 plus or minus 4 radical 5 over 8. Well, now the 2 and the 4 and the 8, those three terms, they have a 2 in common. So this one could be reduced by 2. So if you divide here, here, and here by 2, you're going to get a 1 plus or minus 2 radical 5 and then a 4 on the bottom. Okay? Now be careful. 2 and 4 have something in common, but you can't just choose to reduce part of the fraction. Because the 1 doesn't have anything, this is done. You wouldn't be able to go any farther there, right? Similarly, if you had started with like a, I don't know, a 6 plus or minus radical 3 over 12. Right now the 6 and the 12 have something in common, but the 1 that is in front of the radical does not have anything in common, so this is not reducible. And you definitely can't reduce out of a radical and in a radical, and you can't just choose to reduce two parts of the fraction. So you're going to try to simplify the radical, and then you can only reduce if all three of the numbers there have something in common. So the constant, the coefficient of the radical, and the constant here. If those three things have something in common, that would be the only time you'll be able to reduce. Okay? So let's try this out. Reduce the fraction. If you can, if and only if all three parts have something in common, and then you'll end up with your exact answers. Now, later in the unit, we're going to look at word problems where it's going to be more appropriate to approximate those answers, so you should be able to approximate them. That just means stick them in the calculator and get decimals, if necessary. Okay? So, number one is, in my opinion, the perfect candidate for this quadratic formula. You can't factor it, you can't square root, and if I was going to complete the square, I would have to take half a -5, and that would be -5 halves. I'd have to square that, add a fraction to both sides, just not what I want to do. So this is, for me, a perfect candidate for this process. So I'm going to say here that a is 1, here b is -5, and then here c is +1. So x is going to equal the formula, if I can get them both in the picture here, I don't know. The formula has a negative, and then it has b. So a negative, and then my -5 goes in parentheses. And then the formula has a plus or minus, and then a radical, and then b squared. So in parentheses, -5 squared, and then a -4, and then an a and a c. So a is parentheses 1, and c is parentheses 1. And that whole thing gets divided by 2a, so 2 parentheses 1. Okay? So sometimes that's the hardest part there. Let's get it all plugged in and make sure we use parentheses. Now, let's try to clean it up a little bit. Right here, we have a negative, which makes a +5. So we've got 5 in front of the plus or minus, and then under the square root, you want one number. So I'm going to use my calculator, figure out what that one number is. Now I'm not going to put the radical in, just the radicand, what's under the radical. So in parentheses, a -5 squared, and then -4 parentheses, oops, I actually typed the minus in there, 4 parentheses 1 and 1. So we end up with 21 underneath the radical. And then on the bottom, 2 times 1 is 2. Now, radical 21 can't be simplified, which means because that can't be simplified and the 5 and the 1 and the 2 have nothing in common, that this here represents my 2 solutions. So 2 solutions, these are the 2 exact solutions. If we wanted to approximate, then in the calculator, we're going to put in 5 plus radical 21 over 2, put in 5 minus radical 21 over 2, and see what we get for decimals. And I'll show you how to do that in just a second here, okay? So in the calculator, if you want to approximate this, 5, let's make a fraction first. 5 plus square root 21, all divided by 2, is about 4.79. So here I'm going to say x is about 4.79, or if I change the plus to a minus, let's just say 0.21. 0.21. These would be the two approximate answers. Now, the exact answers are preferred if there's no context, but when we get to context word problems, those approximate answers or the ability to approximate answers is going to be necessary. Okay, so we got the two exact solutions. We'll stick with those. Well, let's look at the next one. Let's try this again. Again, this is the perfect candidate for this formula because you can't factor, you can't square root, and completing the square would create a mess. So here, a is 3, b is 2, and c is 7. So x is going to equal a negative and then b plus or minus the square root of b squared, so parentheses 2 squared, minus 4, and a and c. And that whole thing gets divided by 2 times a. So if we clean this up, negative times 2 is negative 2. Then we have a plus or minus square root of, underneath the radical there, come on, calculator. Okay. Underneath the radical there, I have 2 squared, and then minus 4 and 3 and 7. And that gives me a negative 80. And on the bottom of the fraction, 2 times 3 makes 6. Now this one we can simplify because 80 is a number we can break down there. So if I was to break down the radical 80, negative 80, that's 2 and 40. Well, that's 2 and 20, and that's 2 and 10, and that's 2 and 5. So I'm going to be able to take out 2 2's, which is 4, and because it's negative, I can take out an I. So this becomes negative 2 plus or minus. The radical becomes 4 and I, and radical 5 is what's left over. And then on the bottom of the fraction, the 2 times the 3 was 6 there. Now this fraction is, now that we've simplified the radical, this fraction is reducible because the 2 and the 4 and the 6 have a 2 in common. So if I reduce by 2, then I end up with negative 1 plus or minus 2i radical 5, and then 3 on the bottom. And those would be my two exact solutions here. Okay, that was a little bit messier, not always so nice as the first one where we didn't have to simplify. Now number 3, if you'll notice, is not in standard form. If I want to use the formula, it's got to be all multiplied out. So I want x times x to make x squared, x times 3 to make 3x. Then I'm going to subtract the 4 over to make it equal to 0, and again put it in standard form. So here, 1 in front of the x squared is a, b is 3, and c is negative 4. So x is going to equal a negative 3 plus or minus the square root of 3 squared minus 4 times 1 times negative 4. Be really careful with your signs in there. And then on the bottom, 2 times a, so 2 times 1. So this is going to be a negative 3 plus or minus, what do we have under the radical? So under the radical, we have 3 squared minus 4 times 1 times negative 4. And that's give 25. So 25 under the radical this time, and on the bottom 2 times 1 is 2. Which means this can be simplified further because we know the square root of 25 is 5. So now we're looking at negative 3 plus or minus 5 over 2. Now the others we stopped once we simplified the radical, but that was because I couldn't combine a radical 21 and a 5 or a 2i radical 5 and a 1, but here I can continue, right? This is saying that negative 3 plus 5 divided by 2 is an answer, and negative 3 minus 5 divided by 2 is an answer. And that means, let's see here, And negative 3 plus 5 is 2. 2 divided by 2 is 1. And negative 3 minus 5 is negative 8. Divided by 2 is negative 4. So our two solutions are 1 and negative 4. Now, those solutions worked out a lot nicer than the others, and that's for a reason. And maybe some of you recognize it in the beginning here, but if you look at this equation here, x squared plus 3x minus 4, do you notice anything? If you didn't notice it in the beginning, do you notice now? Well, this equation is factorable. What are the factors in negative 4 that make 3? Well, they're positive 4 and negative 1. And so this thing factors into x plus 4 and x minus 1, which means the solutions would be negative 4 and positive 1. Same solutions that we got using the quadratic formula. Now, I showed you this for two reasons. One, to reinforce the quadratic formula can be used to solve any quadratic. So if you're one that struggles with factoring, or if you just don't want to have to choose a process to solve, you can use the quadratic formula every time. But in my opinion, what we did here in the pink is a lot easier than all that work we did with the quadratic formula. So you're going to have your choice. If you notice that something is factorable, don't use the quadratic formula if you don't like it. But if you are struggling with factoring, or if you're struggling with deciding what method to use, the quadratic formula works every time. You just got to make sure you can simplify all the way through. Okay? Now the last one here, which I put on it as a U try, is another one that's factorable, but because it's going to lead into what we're going to do, I want you to try to use the formula to solve. If you want to try, right? Then pause the video and give it a shot. If not, then let's work this out here. Pick red. Oops. Okay, so A is going to be 4, B is going to be 4, and then C is going to be 1. Again, this is factorable. In any other situation, I would use factoring to solve, but because this is going to lead into what we're doing on the next part of the notes, let's use our formula. So x is going to equal a negative b plus or minus the square root b squared minus 4 times a times c, all divided by 2 times a. So we end up with a negative 4 plus or minus the square root of, oh my goodness, I am so sorry, square root of, I was just trying to get my calculator, of 4 squared minus 4 times 4 times 1. And that gives me a 0, a goose egg under the radical. And then on the bottom, 2 times 4 makes 8. Well, now that we got a 0 underneath the radical, what is the square root of 0? Well, it's just a 0. Negative 4 plus 0, negative 4 minus 0, are those different things? No. So if the radical is 0, it goes away, which means now we just have one solution here, negative 4/8, and that reduces. So we're going to say x equals a negative 1/2 is our solution. Okay? All right. Now, you've got all the ways to solve quadratics. You're going to use the way that you think is best for you or best suited for the problem. Even if you're working on a practice, or a quiz, I'm not going to dictate which method you should use to solve. If you're working on your homework, same thing. I don't care what it says to do to solve, you use the method that's going to work best for you or for the situation, okay? So now we're going to take some time to look at our solutions. Now, if you notice in these 4 problems, we got a good variety of solutions, and we've talked about what some of those look like in our first set of notes, but there are 4 possibilities. 4 possibilities for solutions. Now, if we look at these solutions, if you were to describe in number 1 here, the 5 plus or minus radical 21 over 2, what kinds of solutions are those? So they're real solutions, but they are irrational. When you put that radical 21 in the calculator, you get that non-repeating, non-terminating decimal. So here we had, what's the color I haven't used? Gray, I guess. This was 2 real and irrational solutions. Okay, how about the next one? This negative 1 plus or minus 2i radical 5 over 3. Well, because we have an imaginary here, we end up with 2, we could say, complex or imaginary solutions. Now if we look at these two solutions here, these are two real solutions, but these ones are rational. Two real rational solutions. Okay, and then if we look at these, this is just one solution, right? This is one real rational solution. And these are the things that can happen. One of these four things will happen every time you solve a quadratic. So 4 possibilities. Now, what is it that distinguished between these 4 different options? Why were the first 2 irrational? Why were the next 2 complex? Why were the next 2 rational? And why was the last one just one solution where the other 2 all had 2? All of that is determined by what's going on underneath the radical. If you look underneath the radical here, this was the reason this didn't work out so nicely, okay? If you look under the radical here, this negative 80 was the reason this ended up being complex or imaginary. If you look under the radical here, the fact that this was a 25, a number we could square root, that is the reason why this ended up working out to be 2 nice rational answers. And here, if you look under the radical, the 0 is the reason we ended up with just one solution. That 0 made the radical go away. Okay, so that part under the radical is dictating what these solutions will look like. Okay, we call that thing under the radical, this radicand, this thing under the radical, we call it the discriminant, because it discriminates between the types of answers you get when you solve a quadratic equation. So there are 4 possibilities for solutions. They are based on what we call the discriminant. Discriminant. Sorry, I had to sound that out. Okay, so the discriminant, the formula, is b squared minus 4ac. It's that radicand of our quadratic formula. So what happens is if we get a positive perfect square, so that was like the first, or like the radical 25, right? If we get a positive number that is a perfect square, then we're going to get 2 rational solutions. If we get a number that's positive but not a perfect square, that was like a radical 21 that we saw in the first one, then we still get 2 solutions. They're still real, but they're irrational. So 2 irrational solutions. If we get a negative number, what do we see? Negative 80, whether it's a perfect square or not. If the number under the radical is negative, then you're going to get 2 complex or imaginary solutions. And then lastly, if we have a 0 under the radical goes away, and that would be the only case where you get 1 rational solution. So you may be asked to just determine what the solutions look like. How many solutions are there? Are they rational, irrational, complex? So not actually asked to solve. And to do that, you're going to use the discriminant. So we're using the same A, B, and C. We're just not going through the whole quadratic formula process. So the discriminant is the b squared minus 4 times a times c part. So here, just so that I don't screw anything up, negative 12, and make sure again you're using parentheses when you plug in, negative 12 squared minus 4 times 9 ends up being a 0. So that means this equation, if I were to solve it using the quadratic formula, I'd get a 0 underneath the square root. The 0 underneath the square root makes the radical go away, and this tells me this equation only has 1 rational solution. Okay, so based on the discriminant of 0, 1 rational solution. Here, let's see, this is 10x squared minus x minus 2. So a is 10, b is negative 1, and c is negative 2. So the discriminant is negative 1 squared, negative b squared, minus 4 times a times c. So this discriminant is, let's see, negative 1 squared minus 4 times 10 times negative 2, and we end up with 81. So if I was solving this with the quadratic formula and I got an 81 under the square root, I would be able to take the square root of 81, get a nice 9 that I could add or subtract from whatever was in front of it. So this tells me this equation is going to have 2 rational solutions, 2 rat souls. Okay? All right, here, let's see, a is going to be 1, b is going to be negative 5, c is going to be 3. So this discriminant is b squared minus 4 times a times c. So we end up with, and if you can do some of these in your head, awesome. I don't want to goof anything up. Negative 5 squared minus 4 times 3 and 1. I know those are out of order, but it doesn't matter. We get 13. So if I was solving with the quadratic formula and I got a 13 under the radical, that's going to give me that non-repeating, non-terminating decimal. This tells me this equation is going to have two irrational solutions, two ear souls. Okay, now the last one, if you want to try, you can pause and give it a shot, but based on the 4 options and the 3 we've already had, I'm hoping you can deduce what your answer should be. In any case, A is 1, B is negative 2, C is 4. So we have negative 2 squared minus 4 times 1 times 4. That is going to be negative 2 squared minus 4 times, was it 1 and 4? And 4. And that's going to give me a negative 12. So if I had a negative 12 under the radical, it doesn't matter what the 12 or whatever that is, whatever, perfect square or not. If it's a negative under the radical, this equation is going to have two, we can say complex or imaginary solutions. And you don't have to say both every time, I'm just giving you the options, okay? So you should be able to determine what the solutions of a quadratic will look like without going through all the solving process. And then the last thing we're going to be asked to do, again, deals with solutions. It's the reverse of what we've been doing all along. Instead of here's an equation, find the answers or tell me about the answers. It's here are the answers. What quadratic equation produced those answers? So we have to work backwards and find an equation that produced those answers. Now that might sound kind of tough, but let me go through an example with you here. If we started with x squared plus 4x plus 3 equal to 0, and I said solve it. Well, the factors of 3, they make 4, 3, and 1. And so you would say this factors into x plus 3 and x plus 1. And that means here that negative 3 is a solution. And that means here that negative 1 is a solution. So all we got to do is work backwards. We're going to figure out, we have these answers now, what equation makes that happen? But instead of trying to jump all the way to this step, could we not just jump to this step first? Right? If negative 3 is an answer, it's because x plus 3 had to be a factor. And if negative 1 is an answer, it's because x plus 1 had to be a factor. So if I can write the factors, then I can multiply those to get my equation. So let's say my solutions were 5 and negative 2. If 5 is a solution, it's because x minus that 5 was a factor. And if negative 2 is a solution, it's because x plus 2 was a factor. Now all I have to do is multiply this out to figure out my equation. Okay, so what seemed difficult is actually not that bad, right? Here's the gist. If a number, some number, is a solution to a quadratic, then x minus that number is a factor, right? So it's the opposite of the number that goes in the factor. So you're going to plug the opposites of the solutions into factors, and then you're going to multiply the factors to get your standard form of your equation. Just make sure that you have the whole thing equal to 0, otherwise it technically isn't an equation with any solutions, okay? So I think this is literally, okay, so close to what I just showed you a second ago. If 5 is a solution, x minus 5 is a factor. If negative 1 is a solution, x plus 1 is a factor. So now if I multiply, I get an x squared 1x minus 5x minus 5, combine like terms, so x squared minus 4x minus 5 equals 0 is my equation with those solutions. Alright, how about this guy? Remember our bottoms up? If 2/3 is an answer, it's because 3x minus 2 was a factor. Right? If there's a plus 2 here, that's why I have a minus 2 here. If there's a divide 3 here, that's why I have a times 3 here. Or think about your bottoms up, right? your bottom of your fraction is your coefficient, and the top is your constant. So if 2/3 is an answer, 3x minus 2 is a factor. And then here, if negative 1/4 is an answer, so divide 4 here means 4 has to go in front of the x, and then instead of a -1, +1. And now we just have to multiply this out. So that's going to be a 12x squared, a 3x, a negative 8x, and then a -2, and then combine like terms. So 12x squared, 3 and -8 makes it -5x, equals 2, and there it is. Okay, not so bad. Now, here's the tricky one, x equals 3. Now we know that we can have a quadratic that has just one solution, but how do we make two factors and multiply it out and actually get that quadratic? I want to take you back to the one that had one solution. Actually, there's a couple here, but we said, let's go to this one. Right, this equation had just one rational solution, 4x squared plus 4x plus 1. So let's look at that a little closer. We said 4x squared plus 4x plus 1 is an equation that had just one rational solution. And I solved it with the quadratic formula, but so you can see what's happening here. Let's factor this guy. 4 times 1 is 4. Factors of 4 that make 4 would be 2 and 2. If I divided those factors by 4, then they both reduce to a half. And so I have 2x plus 1 as a factor and 2x plus 1 as a factor, which means I get negative 1/2 as an answer, and I get it again here. It's just redundant to say it twice. So we just say x equals negative 1/2. So when you get one rational solution, it's not because the equation has one solution. It's just because it's the same solution twice. So it's the same factor in the equation twice. That's why we don't see it twice, okay? So here, when it says x equals 3 is the only solution, it just means x equals 3 is the same solution twice. That's what happens. So that means x minus 3 is a factor twice. So we have an x squared, a minus 3x, a minus 3x again, and a plus 9. Combine like terms, and so our equation is x squared minus 6x plus 9 equals 0. Okay, now I think those are the straightforward ones. Here's where it starts to get a little ugly. But we're going to use the same process, okay? And if you can think through this another way, and you'll see what I mean in a minute, you can shortcut this process. But this is saying that 2i is a solution and that negative 2i is a solution, right? So we can use the same process, right? If 5 is a solution, we said x minus 5. So if 2i is a solution, let's say x minus 2i is a factor. And if negative 2i is a solution, let's say x plus 2i is a factor. Now I know we don't normally factor and see things that look like that, but the property is true, and so if we multiply this out, we should still get our equation. Now, if we multiply this out, what's x times x? X squared. Now this is weird. X times 2i, let's call that a positive 2xi. Well, what happens here is we get a negative 2xi, and then here, negative 2i times 2i is going to be a negative 4i squared. Now these cancel, and if you knew that was going to happen, good, because we multiplied conjugates. Those middle terms should have canceled. So we're dealing with the x squared that's left, and then this over here. Now remember what I squared is? I squared we defined as a negative 1. So this is really a negative 4 times a negative 1. Just make a little note here, remember. I squared equals a negative 1. So we have x squared plus 4 equal to 0 as our equation. And that should make total sense. If you were to solve this equation, what would you do? Well, you would subtract the 4 over, and then you would square root. And what do we put for that? Plus or minus square root of negative 4 is 2i. So if you saw this without doing all that work, totally fine for you to jump to your equation. Okay? If not, pretend I didn't say that. All right, one for you to try. Again, kind of ugly, but works the same way. So if you want to give it a shot, go ahead. If you want to just work along with me here. This is saying that 2 radical 3 is an answer and negative 2 radical 3 is an answer. So we're going to put x minus a 2 radical 3 and x plus a 2 radical 3. So these are conjugates. Again, middle terms are going to cancel. So I just need the x and x to make an x squared. And then this is going to cancel with this. And so I'm going to skip to here, which is going to give me a negative 4 radical 9. And radical 9 is 3, so this is really negative 4 times 3. And what's negative 4 times 3? It's going to be a negative 12. And so x squared minus 12 equals 0 is our equation. And again, that should make sense. If you were to solve it, you would add the 12, and then you'd square root. And you'd get plus or minus, you'd break this down, and a 2 would come out, and a 3 would stay. And there it is. Okay? So there it is, guys. Using the quadratic formula, if you like that option for solving, or if you need that option for solving, determining what the solutions look like based on the discriminant, and then using given solutions to work backwards and write equations. So hopefully all good.